Hi guys, and welcome back. So this is the second day of reflections. So you will be able to reflect across more lines of reflection after this lesson. So this first example has you graph the points to form a figure. You'll reflect each figure over the line y equals 2, and that is already drawn on the first graph. You'll have to draw it on the others. And then you'll draw the image in a different color, rewrite the coordinates, and then find a pattern. So I'm going to go ahead and graph all three triangles. So just like we did for reflections day 1, we want to count how far our triangle, each point is from this line of reflection that goes through the line y equals 2. Remember in Math 1, you probably heard the acronym HOI and BUCS. So remember, horizontal lines have a 0 slope and go through the y-axis, or have an equation that is y equals some number. And VUX was for vertical lines. They have an undefined slope, and they go through the x-axis, or they have an equation of x equals. So since it's y equals 2, then it's a horizontal line through 2. So I'm going to count how far each point is away from the line. So this point 2, 4 is going to be 1, 2 away. So I'm going to count down to 2. So it's actually going to now be at 2, 0. 4, 1 is 1 away, so we're going to go 1 above it. So it'll be at 4, 3. And then 1, 2 is on the line, so it's going to stay on the line. So stay at 1, 2. So you can see that it reflected over, and you can see that these points that were on the line are intersecting the line of reflection. So that helps you to see where your line of reflection is. And also everything is the same number of points away from that. And it's just flipped over if we folded it there. Looking at the second one, looking at the point -1, so drawing in our line again, so it goes through here, we can see that these 2 points are already on the line, so they're not going to move. So just go ahead and write them in the table. And then this point here is 2 away, so we'll go 2 up. So there is your line of reflection in between. It's folded up on top of itself. So that's at the point -4, 4 now. You do the third one. So you should have seen that your triangle just flipped right over. This point comes down, the other points go up, and you get these points -1, 5, 2, 1, and 6, 6. So there's not really a rule for figuring out how to reflect over a horizontal line. So the process is that you will draw the line of reflection and then reflect by counting. So you draw that line of reflection, count how far away it is, and then just make sure you count straight to the line up or down, and then keep going in that same direction. On this example, we are going to graph the points to form a figure. We are going to reflect in the line x equals -1 now. It's drawn on our first graph, and then we will write the coordinates and find our patterns. So I've drawn the first triangle here for us. Remembering the VUX, so a x equals line is vertical through x equals the number that it is. So just like we did before, we're going to count how far away we are and then keep going in that same direction to get our new points. So we see where these points will all lie. Did I count that right? 1, 2, 3, 4, 5. No, I did not. Didn't go quite enough. 1, 2, 3, 4. Here we go. So we graph those lines, those points, and we see that reflection with the line in the middle. So then when we write our points out, 1, 1 went to -3, 1. 4, 3 went to -6, 3. And 2, 4 went to 4, 4. If it's helpful to you, draw a highlight on your axis. Sometimes with the vertical and horizontal lines, it's hard to see the axis when we graph them. All right, so we're going to do the same thing on the next one, only now we're still going through x equals -1, so we're just going to draw our line. Again, this point is on the line, so it doesn't go anywhere. And then we're just counting how far away everything is and regraphing it. So we can see how our points look. So the point -1, -2 stays the same. The point -2, 3 went to 0, 3. And -4, 4 went to 2, 4. And so what ends up happening is you get your points. And again, there's no real rule. So we're just going to remember that we are drawing the line of reflection and then reflecting by counting. Always remember you want to count directly over to the line so that you make perpendicular bisecting lines to each other. On to the next piece. Now we're going to graph these and we are going to reflect over the line y equals x. So the line y equals x is the line that has a slope of 1 through the origin 0, 0. So on this first graph, we have it graphed. And the trick to these is to make sure that you count straight up or down or over to the line and then go the opposite direction. Remember, perpendicular lines have slopes that are opposite reciprocals. So if we want to, if the slope of our line is 1, then we need to count and find a -1 slope to it. So if I go down 1, I hit the line, so I need to go back over 1 to get that line. So then we know that slope of between these 2 points is -1 over 1, which would be the perpendicular slope to a +1 over 1. And so when we do that, then we find that that point is there. So this is the point 3, 2, 3, and it went to the point 3, 2. And then we're going to do the same thing for the point 1, 5. I'm going to go down 1, 2, 3, 4, and then I'm going to go over 1, 2, 3, 4. So it's not going to be in the same direction like it was for our horizontal and vertical lines. Because with the horizontal and vertical lines, we wanted to keep the same direction to keep a perpendicular slope. So, but this one, because it's slanted, we want to make sure, and it has that slope of 1, we want to give a line that would have a slope of -1. So that meant we went down 4 and over to the right 4. You could have also gone to the right 4 and down 4, and you would have ended up at the same spot. But I always go down and over because that's how we do our slopes. So that point 1, 5 ends up at the point 5, 1. And then doing 3, 4, we go down 1, and then we're going to go over 1. So we're going to end up at the point 4, 3. All right. So I'm going to just put on my graph here in blue. It's not dotted, but it'll be okay. It'll be easier for you to see it if it's not dotted. Now we're going to do the same thing with these points. So the point -3, 4 is right here. So I'm going to count straight down 1, 2, 3, 4, 5, 6, 7, and I'm at my line. So I went down straight 7. So then I'm going to go back over 1, 2, 3, 4, 5, 6, 7. So that point is now going to be at the point 4, -3. And then the point -2, 0, I'm going to go down 2. So I go over 2. It's now at the point 0, -2. And -6, 2, I go down 1, 2, 3, 4, 5, 6, 7, 8. Then I go over 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to be at the point 2, -6. You try and reflect the third one. All right, so when I was reflecting that, I realized that my original triangle was graphed wrong. I fixed the black triangle and then did the new triangle. You should have gotten the coordinates -3, -2, 5, 3, and -2, 4. So if you notice, all of my x's and y's stayed the same, but the order switched. So the x became y and the y became x. So we can actually write a rule for this transformation, this reflection. So when you reflect on the line y equals x, your point xy will map to the point yx. So you just change the order of your coordinates and you will have your new points. So now let's see what happens when we are graphing in the line y equals negative x. So this is going to be the line that goes to the origin and has a -1 slope rather than a +1 slope. So just like before, I'm going to go down to my line. So I went down 4 there, and then I'm going to go back over that same amount. So we're still making those -1 slopes, or now we're making +1 slopes to be perpendicular to our -1 slope. So since I went down 4, I need to go over 4. So I'm at the point -1, -3 for that first point. For the point 2, 6, I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8, and go over 1, 2, 3, 4, 5, 6, 7, 8. And then so that brings me to the point -6, -2. And for the point 5, 3, I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to go over 1, 2, 3, 4, 5, 6, 7, 8. It's like we're in a dance company, right? So that's at the point -3, -5. When I draw my lines in there, I see that if I folded my paper on this line, my triangles would match up. So drawing in the y equals -x line again down here. Counting down 1, 2. So then I'm going to go over 1, 2. And you always make sure you go through the lines. If I'd gone down 2 and went over 2 this way, I didn't cross the line. So that would be the wrong direction. This went up 1, so it goes over 1. And then this one goes up 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And so then we can see our triangle reflected over that line again. So the point 0, 2 went to -2, 0. -3, 2 came over here to be -2, 3. And this point -5, -3 came over here at +3, +5. So go ahead and do the last one and then come back to check. So once you've reflected that, you should get the points -2, -1, -5, 3, 2, -4. Just like before, our x's and y's changed order. So what was y became x and what was x became y. But this time they both changed signs. So we started at the point +3, +1 and ended at the point -1, -3. So to write this rule, we're just going to write that xy will map to the point -y, -x. So you're going to change both signs and change the order for this particular reflection. So make sure that you've got your algebraic rules written down so that you can use them to help you do examples. We will work examples with this tomorrow in class. If you have any questions, please bring them to class with you, and I will see you then. Have a great day.